This is problem number 6 on the sample test problems for test number 3. Use L'Hopital's rule as many times as is appropriate to find the following limit. Limit as x goes to 0 of sine x minus x over x cubed. Just to be crystal clear, it is not this. If you put parentheses in, you are changing my problem. If you really need parentheses there to make it clear, it's sine of x, that whole thing, and then subtract x when you're done. Okay, so first thing to do whenever you see a new limit is to just plug in. So if you plug 0 in everywhere, we get sine of 0 and then subtract 0, divide by 0 cubed. So lots of zeros floating around here. Sine of 0 is 0, 0 minus 0 is 0, 0 cubed is 0. Okay, so 0 over 0 maybe is not so surprising because I told you were going to use L'Hopital's rule. But still, the first time you see a limit, you just plug in and hope that you don't get 0 over 0. If you get something else, then a lot of times you're just going to be done. So L'Hopital's rule, I'm going to go ahead and put a little LH up here to indicate what I'm doing. L'Hopital's rule says when you get one of those indeterminate forms, 0 over 0, you get to take the derivative of the top and bottom separately, not the quotient rule, and then take the new limit. So the derivative of sine x is cosine x. The derivative of that x is just 1, so it's minus 1. The derivative downstairs, again, it's not the quotient rule, it's 3x squared. And now I have a new limit, so guess what? Plug in. All the x's become 0. Cosine of 0 is 1. 1 minus 1 is 0. 3 times 0 squared is 0. Oh, shucks. 0 over 0, meaning there's more work to do. So let's do some more work. And that more work is another application of L'Hopital's rule. I'll indicate it there. So again, going back to the purple thing right above, take a derivative of top and bottom. Derivative of cosine x is negative sine x. Derivative of that subtract 1 is nothing. Divided by derivative of 3x squared is 6x. It is not the quotient rule. And now we have a new limit. So what shall we do? Plug in. All the x's become 0. So we get negative sine of 0 divided by 6 times 0. Let's see, negative sine of 0 is negative 0 divided by 0. So we get 0 divided by 0. Clear indication your math teacher hates you. So let's try one more time. Another 0 over 0, so another application of L'Hopital's rule. Take a derivative upstairs and downstairs. Derivative of negative sine x is negative cosine x. The derivative of 6x is 6. Thank goodness. There's no way we're going to get another 0 over 0 when we plug in. So all those x's become zeros. 6 is just 6. Negative cosine of 0 is negative 1. Divided by 6. So that's our answer. And just for kicks, let's see if the calculator can confirm that behavior. So going all the way back up to the original function, it was sine x minus x. And then it was divided by, was it x cubed? I think it was. Okay, and now I'd like to plug in numbers really, really close to 0. So I'm going to go into table set. I'm going to change the independent variable to ask. And now that I've done that, we're going to go ahead and go into the second table. And we're going to put numbers here for x. So you're putting numbers that are close to but not equal to 0. So I'll put numbers like 0.1 and 0.01 and 0.001. And just because I'm a rebel, I'll put 0 in anyway. Okay, fine. And then we're going to put numbers that are near 0, but on the left side. So negative 0.001, negative 0.01. We're getting further from the answer here, but I do like the symmetry when the table is done like that. And so it sure feels like, and one thing I should have double checked was the mode. So make sure you're in radian mode when you do this. And my goodness, it sure feels like we are very quickly approaching negative 1/6. So I don't know if you recognize that decimal, but it is the decimal approximation for negative 1/6. To be clear, these numbers are not exactly the same. You get more detail when you highlight the number. You can see there's all the details. So here it's 2 6s and then a 5/8. And if we go up 1, it's now 4 6s and then a 5/8. And if we go up 1 more, looks like 6 6s and then a 5, probably an 8 there. So confirmed graphically from the table. And of course, using L'Hopital's rule is the way to make sure you get it right.